Hello everyone, welcome back to the section 5 of this course in which we are going to be exercising the distributed network logarithms which we studied in our earlier section. The first video will be about the base node logarithm, and then we will be writing the floating logarithm on top of that. As we studied before, the simple asynchronous logarithm for floating is a gateway node ng sends a message to all of its neighbors. Then when node ni receives message from its neighbor nj, if ni has never seen this message before, only then ni sends it to all of its neighbors except the origin node. Else, if ni has seen this message before, it is simply going to discard. Following this logarithm, the message m is propagated to all of the nodes in a network. Taking the simple example of a given network where D is the gateway node, NG, that sends a message to its neighbors, B, C, and E. Currently, all three of them have seen this message for the first time, so they are going to propagate this message to their neighbors. First, B sends to A and E. Here, E discards a message from B because it's already received from the node D. Similarly, node C sends the message to all of its neighbors. In this case, node A is going to discard the message from node C because it was already received from node B. And similarly, keep on continuing this logarithm will eventually gonna reach one point where all of the nodes will receive this message M. So to present a node with their ID, we are going to create a structure presenting node names and IDs, then creating a list of this structure, node name ID record. Of course, here you have to change the node IDs matching to the chip ID of your nodes by keeping the names as it is. Then we will define some helper methods to get the node names by IDs and node ID by name. Moving on, then we will define a structure for neighbors in which we will have a node name with its corresponding neighbors list. Then we will create a list of this structure, all nodes neighbors list, which will be presented in this way for the given network structure. So A has neighbor B and C, B has neighbors A, D, and E, and so on. And defining the helper methods to send the message to all of the nodes. I have mentioned the comments on each line, so I don't have to go through explaining line by line, but I guess it's pretty simple and straightforward to understand what's happening here. Another similar method, which will be doing exactly the same thing, but sending message to all of the neighbors except the origin. Here is the JSON message structure that will be used to send the messages across the nodes in a network. Now, for those of you who don't know what CRC is and why we are using it here, let me give you a very simple example. So we have a message M that has data hello and time with some epoch timestamp. Think of a CRC as a magical function that takes in a string and it generates a random fixed integer value, which is known as CRC. Now, if any single character of this message is changed, the whole CRC of that message is going to be different than the initial one. So this gives us an advantage of calculating and identifying the errors in the network. Now, let's say this message was sent from node N1 to its neighbors N2 and N3, which then received the CRC of that message. And from there, node 3 sends the exact same message to node N. Then node N will say that, oh, I already have the CRC in my list, so I am going to discard this message. And the similar thing happens in node 3 when the same message is sent from node 2. Similarly, all of the nodes are going to keep a record of received CRCs to make sure that they are not receiving any duplicate messages. Out of a lot of given libraries of CRCs in Arduino, we are going to be using this one. You can download the zip file of this library from the GitHub page and add it into the Arduino library. Calculate CRC method is defined this way, and then some of the helper methods are store receive message CRC, which stores the given CRC into the internal cache memory of the node. And another helper method, which is called isDuplicateMessage, is defined to check whether the given CRC already exists in our cache memory or not. Then the very important method for this CRC is validateReceivedMessage, which extracts this received CRC and it calculates the CRC of the given message and compares both of them. If they both match, which means that the content of the message sent from the sending node is exactly the same received on this node. If at this point the CRCs doesn't match, then that means that the message was altered in some way on the communication channel between the sender and the receiver. It can be due to noise or any other factors like data tampering, hacking, etc. So once the CRC is calculated, we then have to take the decision to discard the message if it is duplicate, otherwise accept this message. Okay, so first of all, you have to make sure all the nodes are fully charged and exact same code is uploaded in all of the nodes. Then connect the gateway node. In this case, it's this one, node D, which is connected to my laptop via USB cable. Now let us turn on all of the nodes. Now looking at the logs of gateway node, it's scanning the network and it found 5 nodes, including this one makes total 6 nodes. So that means all of the nodes are connected with each other now. Now let us send a message formatted as F. F stands for floating, followed by semicolons. Then type in any message that you want that will be propagated into the network. Let's say hello. Press send. And voila, yes, as you can see, it has been propagated through all of the nodes, and in some of them, we have received duplicate messages, from which we can clearly see that the message which was propagated from the gateway node went all the way from node B, A, C, F, then from B to E as well, which results in the message completely distributed across all the nodes in a network. Now, some of the messages that got discarded are on node D from C and E, and also node E discarded from D and F. Now, looking at the characteristics of floating logarithm, which we studied in our section 3, we can see that the total number of messages in this example are 10, which we know that is not the worst case scenario. And I'm sure you still remember what worst case scenario is for floating logarithm. Not every execution is acceptable. Yes, that's true. In some cases, we are receiving duplicate messages and are getting discarded. Every execution is depending on the order in which they are delivered. Yes, exactly, because we are not going to get the exact same results on the next run. It all depends on when a message is received on another node.